Sets. We have already learned some conventions for set notation. Let's briefly review some of them. We know that we use a capital letter to denote a set. We know that we use curly brackets to contain the members or elements of a set. We know that we use commas to separate the elements in a set. We know that we use the ellipsis to represent members of the set that have not been written. We know that the E means is an element of, for example, in set A, when you look at the elements of the set A, number 2 is an element of set A. We know that the E that has been crossed out is not an element of. So in set A, when you look at the elements, you see that the number 5 is not an element of set A. Now we're going to learn another convention used in notation of sets. Look at this set. How would you describe this set in words? Pause the video and discuss it as a class. Yes, set A is the set of natural numbers divisible by 5. You could also say that set A is the set of multiples of 5. Here is another way of representing set A. Pause the video and copy the slide. Welcome back. Here we have what we call set builder notation. This information here tells us why set A is what it is, and we call it set builder notation. And if it looks a bit tricky, don't worry, it is quite easy to understand. In words, we would say that set A equals x such that x divided by 5 is a member of the set of natural numbers. Set builder notation is easy to understand if we take our time to look at it carefully. Let's take our time to look at it now. Number 1, we know that A denotes the set, so we say set A equals. Set A equals x. X stands for a number, or rather the numbers that will go into making the set. The next piece of information here is this colon, and in maths we read it as such that. So let's go back. So far we're saying set A equals x such that, and then we come to here, x divided by 5 is an element of n, which is the set of natural numbers. Pause the video, copy this down, and different members of the class should try to say it. Let me say it one more time before you pause. Set A equals x such that x divided by 5 is an element of the set of natural numbers. Pause the video and let different members of the class practice saying this set notation. Let's take our time and go over it again step by step. Pause the video at the end of each slide to give the pupils enough time to copy it down. So we know that A denotes the set, so we will say that set A equals set A equals x. X stands for a number, the numbers that will go into the set. set A equals X. Set A equals X such that set A equals X such that X divided by 5. Set A equals X such that X divided by 5 is a member of. Set A equals X such that X divided by 5 is a member of the set of natural numbers. Here is our set builder notation again. Set A equals X such that X divided by 5 is a member of the set of natural numbers. Let's work out and see why 5, 10, 15, 20, and it goes on are the legitimate members of set A. Let me explain it. Please pay careful attention so that you understand this explanation. You see, the set builder notation tells us that we have a set A and that it equals X. In this case, X is a variable. It means that X is some numbers which will change, which will vary, and that's why we call it a variable. But it also tells us that whatever numbers X stands for, when you divide them, the answer must give you one of these numbers in the set of natural numbers, okay, which we know are the numbers we use to count things in nature. So, for example, if we have a number in set A, take the 5, it's telling us that we must divide the 5 by 5. We write 5 under. And when we get the answer must be found within this set of natural numbers. So, for example, 5 divided by 5 equals to 1, which is in the set of natural numbers. So 5 is allowed to be here. Take the 10. 10 divided by 5 gives us 2. 2 is here in our set of natural numbers. So 10 is allowed to be in set A. We can do the same for the 15. 15 divided by 5 gives us 3. And once 3 is in our set of natural numbers, 15 is allowed to be in set A. Look at the 20. 20 divided by 5 is 4. And as 4 is in our set of natural numbers, then 20 is allowed to be in set A. Well, I'm sure you can guess what other numbers can be in set A. What we would like to do, pause the video at this point and just write down 3 other numbers that would be in this set and be ready to explain to the class why those numbers are allowed to be in set A. Here's another example for us to try. Pause the video and write down in words what this set builder notation is telling us. It tells us set B is the set of numbers X such that X, the numbers, are less than 10 and the numbers are natural numbers. Set B equals X such that X is less than 10 and is a natural number. Well, let's pause the video and see if we can write down the elements or members of set B according to this set builder notation. Well, if you've understood it, then we know that set B will have members that are natural numbers, but that these numbers must be less than 10. So we have the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Of course, we don't have 10 because 10 is not less than 10. I hope that is understandable. At the end of the week, enjoy the rest of your day.